Good afternoon. So if you are one of those people who is kind of an artsy person or you like to draw, or maybe you're more like me and you can't draw but you do enjoy coloring, then this lesson's going to be for you. We're going to spend a lot of time drawing and graphing some of our different functions. So quickly, I want to remind you what those functions look like. Okay? The first one and the most basic one we could have is our linear function, and that's just all the different kinds of straight lines. You could have a quadratic. If you remember, we said we call that shape that a quadratic gives, we call that a parabola, but really what it looks like is a hill or a valley. You could have a square root function, which looks like an arrow being shot off into the distance. You could have a cubic function, okay, and that cubic could go either up or down, but that's your squiggle. You could have a cube root function, which is your snake, and again, it could go up or down. And the last one you could have is your absolute value. And to me, absolute value is the easiest shape to remember because value has a V in it, and so does the shape of the graph. It looks like a V. Okay? So we're not going to graph all of those shapes today, but we will be looking at some of them. Alright, so example 1 says graph the function below. And I know that this is a square root function because there's a square root in the equation. So in the back of my mind, I should be thinking, when I graph this, it should look like an arrow being shot off into the distance. If it doesn't, I've probably done something wrong. So here's how I graph any function. I make myself a little table with x and y, and I get to pick some numbers for x. So I'm going to pick some small numbers that are easy to work with. The only thing I have to remember with square roots, I can't pick a negative number, and we'll talk about why later on in this year, but for now, all you need to know is I need to pick positive numbers or 0 for square roots. And now here's what I do. I evaluate this function, so thinking back to our last lesson, for x equals 0. So I say, okay, if I plug in 0 for x, what happens? Well, the square root of 0 is just 0, and negative 2 times 0 is still 0. So when x is 0, so is y. So there's the first point that I plot, 0, 0. Next I say, well, what happens when x is 1? Well, the square root of 1 is 1, and negative 2 times 1 is negative 2. So the next point that I plot is 1, negative 2, which is about right there. Okay? That was a really ugly point. Alright, next one. What about when x is 2? Well, here's the thing. I don't know what the square root of 2 is off the top of my head. You probably don't either. So I grab my handy-dandy calculator, and in my calculator I type negative 2 times the square root of 2, and it spits back out negative 2.8. Roughly, not exactly. But the next point I plot then will be 2, negative 2.8, which is about right there. Okay? And then I say, okay, what happens when x is 3? And again, I don't know what the square root of 3 is off the top of my head. So in my calculator, I type negative 2 times the square root of 3. And this time I get negative 3.5, roughly. So I graph 3, negative 3.5. And then one last point here. This time, what happens when x is 4? Well, I do know that the square root of 4 is 2. And negative 2 times 2 is negative 4. So there's the last point that I'm going to graph. And then all I have to do is connect those dots and put an arrow on the end. And I always have to put the arrow because if I wanted to keep graphing, I could. Okay? I just don't really need to right now. And there's my graph. It looks like an arrow being shot off into the distance, so I've probably done it right. Alright, what about example 2 here? This is an absolute value function, okay? But here's the thing. I'm going to do exactly the same steps. I'm going to make myself a little table. And I'm going to pick some numbers to plug in. So we'll pick negative 5, negative 4, negative 3, negative 2, negative 1, and 0. Okay, and we don't necessarily have to plug in all of those. The reason I picked numbers like -5 and -4, and you'll learn more about this in the next lesson, I saw a 3 in this equation, so I picked numbers like 2 and 1 and 4 and 5. I wanted some numbers on both sides of 3. I think you'll understand a little more in the next lesson why I picked negative ones, okay? So what happens when I plug in -5 for x? Well, -5 plus 3 is -2. But here's the thing. That -2 is inside absolute value bars. What do those bars do to any number? They make it positive. So the first point I'm going to plot is -5, 2. Then I plug in -4. Well, -4 plus 3 is -1. But again, that -1 is inside absolute value bars, so it becomes positive. So the next point I plot is -4, 1. Okay? What about if I plug in -3? Well, -3 plus 3 is 0. 0 is just 0. That's all I can really do with that. So -3, 0 is my next point. -2 plus 3 is a positive 1. Well, if a number's already positive, then those absolute value bars don't really matter. It's already positive. So -2, 1 is my next point. If I plug in -1, -1 plus 3 is 2. So the next point I plot would be -1, 2. And then if I plug in 0, 0 plus 3 is 3. And it made the shape that I think that it should have. Absolute value always looks like a V. Okay? Just kind of a preview to the next lesson. If you see a +3 inside parentheses or inside of absolute value bars, notice how our vertex was at -3. You can tell that just by looking. Your vertex is actually going to swap signs there. That's how I knew to pick a -5 and a -4 and then a -2 and a -1. I picked negative numbers because I saw that sign and swapped it. Okay? All right. Next thing I want to talk about is what's an inequality. That's a word that we don't always use very often. So if you see one of these 4 symbols right here, those are your inequality symbols. It means you have shading on your graph. The less than symbols are the 2 that point to the left. I always remember that I can make those symbols with my left hand. Well, by default, that means the ones that point to the right are your greater than symbols. Okay? So these 2 are your less thans. These 2 are your greater thans. Okay? If you have a line beneath the symbol, that means equal to. So your graph, when you graph it, will have a solid line. If the symbol does not have a line beneath it, then your graph will have a dotted line. So let's actually graph an inequality and see how that goes. So the first thing I notice here, number 1, this graph is going to give me a line. And the reason I know that is because there's no absolute value bars, there's no square root symbol, there's no exponents, there's nothing special about it. The second thing I notice is that this equation is backwards. So before I actually start graphing it, what I need to do is flip it around. I need to write it with y on the left side. So notice this symbol looked like a less than, but I'm going to flip it around so that y is on the left. So it flipped. Okay? So that looks a little more like what you're used to. If you don't flip it around, I can almost promise you will mess up the shading later. Well, for a line, here's the thing. I really only need 2 points to make a good line. So I'm going to pick some really easy numbers. I'm going to pick 0 and 1. Well, what happens when x is 0? Well, 4 times 0 is 0. And 0 minus 5 is -5. So the first point that I plot is 0, -5. What about when x is 1? Well, 4 times 1 is 4. 4 minus 5 is -1. So the next point I plot is 1, -1. And right there, because I know this is a straight line, that's all I need is just 2 points to give me a good line. Now, the reason that I drew a solid line here is because of this right here. That symbol has a solid line underneath it. So I graphed a solid line. What about the shading? Because that's an inequality. That symbol is greater than because it's pointing to the right. So where do my numbers get greater? Well, they get greater at the top of the graph. So here's a good rule of thumb that I use for finding shading. I put my finger on any point on this line. So we'll say I'll go with that one right there. It doesn't matter. And if I have a greater than symbol, I go up from that point. That's the side of the line that I shade on. So I would shade all of that in, and then I'm done. If it had been a less than symbol, I would have put my finger on the same point, but I would have gone down, and I would have shaded on the other side of the line. Okay? Alright, last example here, and again, this looks funny. And the reason it looks funny is because y is not by itself. So how am I going to go about making this equation be in the correct form before I graph it? Well, there's a few steps here, and I'm going to rewrite it right here. I have got to get y by itself. So step 1 is I take the 3x, and I cancel it out, move it to the other side. So if 3x is positive and I want to get rid of it, I subtract it from both sides. So now I have negative 2y is less than negative 3x plus 10. So notice, I didn't combine the negative 3x and the plus 10 because they're not like terms. I simply just wrote the negative 3x on the other side. I canceled it out on the left, moved it to the right. Now I have a negative 2 with y. And that negative 2 is being multiplied. So how do I cancel it out? Well, I divide both sides by negative 2. And I have to divide everything by negative 2. Okay? Now, something that I want to remind you of, if you ever divide by a negative, like I just divided by a negative 2, you have to flip your less than and greater than symbol. So that less than just became a greater than. Okay? Negative 3 over negative 2. Two negatives make a positive. 10 over negative 2 reduces to negative 5. So what did I just do there? Well, to get y by itself, I started by moving the x over, and then I divided. Now y is by itself. Now, this is what I'm plugging things into. So I make myself a little table. Again, I pick two really easy numbers, so I'm going to pick 0 and 1. And my calculator may come in handy now, but I'm going to say what happens when x is 0. If you type in your calculator 3 over 2 times 0 minus 5, you get negative 5. So there's my first point, 0, negative 5. What about if you plug in the number 1? So I grab my calculator, I type in 3 over 2, or you can also think of that as 3 divided by 2 if you want to. So 3 over or divided by 2 times 1 minus 5. And it gives me negative 3.5. So the next point I plot is 1, negative 3.5, which is right there. When I graph this line, it's going to be dotted. And the reason being, if I look at my symbol here, there's no line beneath it. If there's not a solid line in the symbol, there's not a solid line in my graph. Your last step now is to get your shading, okay? Well, that's a greater than symbol. So I pick any point on this line. So I'll pick this one right here. My numbers get greater as I go up. So if I put my finger on that point and I go up, that's the side of the line that I should shade on. And then I'm done. So just to recap there, I started out with a less than symbol. But because I divided by a negative 2, it flipped and became a greater than. Okay? When I plugged in my points, okay, I had a fraction. That's okay. You can type it in your calculator. You can either, if you have a fraction button, do 3 over 2, or you can do 3 divided by 2. That's the same thing. So, some important takeaways here. You have to get y by itself at some point if it's not by itself. So like that last example where y wasn't by itself, we had to get it by itself before we plugged in points. The second thing, make sure y is on the left if you are graphing an inequality. Okay? And that is the end of our discussion on graphing our functions.